Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I am doing, please don't forget to share my videos to your friends and to your friends' friends. That's the only way you can keep me going, refreshed and inspired. Now if you find my videos to be helpful in your studies, then please don't forget to subscribe. By the method of least work, determine all support reactions CI is constant. So here is another problem. Then EI is constant for this case. For simplicity, we will have a bit complicated problem later on. So let's denote the redundant forces at A uh, as the following and the directions. So at D also. So our sectioning would be here, 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 and here. So there are 4 sections as shown in the figure. And third, then fourth. So I hope that you experience the setting up of the moment equation and partial derivative with respect to the redundant in the preceding examples, so that I will not explain it anymore how to set up that or those equations in these equations here. So first, partial of u with respect to AH equals 0 equals integral moment in this equation is AH times x plus MA. The derivative with respect to h is x dx. Then on the second section, considering all forces to the left and below, so we have plus integral of AH times 9 plus AV times x plus MA minus 25x x over 2 or minus 12.5 x squared, derivative 9 dx of this equation. Then for that third section, plus integral of AH times 9 plus AV times quantity 6 plus x plus MA minus 25 times 6 times 3 plus x, derivative 9 dx. And for the last section, AH times, if this is x, so moment arm of AH, which is this moment arm here, is 9 minus x. So integral 0 to 6 of AH times quantity 9 minus x plus AV times 8 plus MA. Then minus 25 times 6 times 5. 3 plus 2 is 5. So that's the moment equation. The derivative with respect to h is 9 minus x dx. So for the first integral, it is 243 ah plus 40.5 ma. For the second integral, it is 486 ah plus 162 av plus 54 ma minus 8100. For the third integral, 162 AH plus 126 AV plus 18 MA minus 10,800. And for the last integral, 234 AH plus 288 AV plus 36 MA minus 27,000. So combining corresponding like terms, setting up the first equation, 1125 AH plus 1576 AV plus 148.5 MA equals 45,900. For the succeeding equations, then it would be easy because we just replace the second factor by the derivative of the redundant force. This time, the redundant force is AV. So partial of u with respect to AV equals 0 equals, we copy the moment equation, then replace this by 0. And plus this equation here, copied. Then we replace this by derivative of AV, which is x dx. Then for the third integral, copy. So we replace this by 6 plus x dx, this one. So MA minus 25 times 60 plus x, then 6 plus x dx. For the last integral, copy. And then replace this by 8 dx. So times 8 dx. So the value of the first integral is of course 0. For this second integral here is 162 AH plus 72 AV plus 18 MA minus 4050. So you verify it yourself by pausing the video if you want to check that. Then for the third integral, 126 AH plus 296 AV over 3 plus 14 MA minus 8500. And for the last integral, we have 288 AH plus 384 AV plus 48 MA minus 36,000. So again, combining like terms, setting up the second equation here, we have 576 AH plus 166 over 4 over 1664 over 3 AV plus 80 MA minus 48,550. Call that equation 2. Then for the last partial derivative of u with respect to MA, so we copy the equation, then replace this second factor by 1 dx or dx only, because the derivative with respect to MA is just dx. Then plus, copy, replace this by just dx. So times dx, then third integral copied, 0 to 2, ah times 9 plus ab 6 plus x plus ma minus, you may replace this by 150 if you want. Then for the last integral 0 to 6, so we replace the factor here by 8 dx also. Sorry, dx, just dx. Our redundant force is ma. So the value of the first integral is equal to 40.5 ah plus 9 ma. Second integral 54 ah plus 18 av plus 6 ma minus 900. For the third integral 18 ah plus 14 av plus 2 ma minus 1200. And for the last integral 36 ah plus 48 av plus 6 ma minus 4500. So combining like terms, setting up the third equation on 48.5 ah plus 80 av plus 23 ma equals 6600. So solving these three equations simultaneously, we get ah equals negative 14.474 kilonewtons, av is 95.708 kilonewtons, and ma 47.507 kilonewton meter. Therefore, our final answer, AH is 14.474, and it should be rightward. Then AV is upward, 95.708 kilonewtons. MA is clockwise or negative, 47.507 if you don't indicate that it is clockwise. Summation forces X, so AH equals DH, so DH is leftward, 14.474 kilonewtons. Summation forces Y, then you can solve dV. Vis-a-vis is 25 times 6 minus 95.708, so 54.272 kilonewtons. Then I will leave to you how to solve for MD. You just sum up moments about D equals 0 and verify that MD is equal to 19.753 kilonewton meter, and it is supposedly negative, or that's the positive final answer. So it is counterclockwise. So that's it for this problem.